Are you okay
yes,
with that?
fine.
Okay.
So I'm a conservation scientist, and I'm interested in helping conservation organizations make better decisions about how they spend money to get the biodiversity outcomes that they want. And so I thought I'd talk a little bit about my thoughts on how we can better think about and get data into the future to support these types of decisions that we have to make as society and as conservation organizations. So a lot of the work that I've been doing lately has been helping the U.S. Fish and Wildlife Service help make decisions about their spending money to get the conservation outcomes that they're trying to get. And so this is working on Endangered Species Act protected species. So that's about 1,800 species that are protected under the Endangered Species Act in the U.S. And estimates are about something about like $1.8 billion a year is required to do all of the recovery plans that, or all of the recovery actions that are mandated by recovery plans under the Endangered Species Act. Really, how much is spent is like 28 million or something like that. You know, the amount of money that is actually spent on recovery is far, 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 far from what needs to be spent. So in situations like this, what we're doing is saying, okay, how can we be as efficient as possible in doing the actions that we can do with the money that we have available? So a recent paper that we just had come out, so Leah Gerber is the lead author and I was one of the authors on the paper. We worked with the Fish and Wildlife Service, took the information that's publicly available in the recovery plans and said, can we use that information to help them order the priority of the actions that they're doing? And so what this figure is showing is if they took cost efficiency into account while they are determining which recovery plans to implement in order, the potential gains from doing that are phenomenal. So this blue line right here is, it's not actual allocation because there was no way of actually figuring out what actual allocation looks like given the available data. But this is if recovery plans were implemented in random order. If they're implemented in efficient order, here's what we get. We get tremendous gains by sort of starting with the plans that have a high benefit from implementing them at a low cost. Now, in order to do this, you need to have some estimate of what the benefit of the recovery actions that you are doing is, and you have to know what the cost is of the recovery actions. Neither of those data sets are very good for any conservation organization as far as we can tell. Here we used the recovery plans. We sort of estimated a guess at benefit given various criteria that they used to determine the things in the recovery plans. And we used the costs that are also in the recovery plans, but they were quite uncomfortable with the costs in the recovery plans because they know that they are sort of rough estimates pulled out of various hats at different points in time. But some of the work that we did was looking at sort of how do we move forward even though we know that this data is very uncertain. Like, can we, I was talking about this a little bit earlier, can we say something about how the decision would change even though we know that these data are bad? So there's ways that you can deal with it, but what I've been pushing, I guess, is how can we move forward into the future as a field to collect data into the future that allows us to sort of think about things like cost efficiency easier without having to go through this exceedingly painful process of retroactively trying to make data fit into the process that we want it to fit. And so this figure I pulled from someplace else, so I'm not sure whether it's really going to work for what I'm trying to say. But what I'm trying to show with this figure is that, so there's a conservation intervention and there's some data that is associated with that intervention. In this case, we're going to start up here. The intervention that I'm thinking about is something like weed management, and the weed management does something. Somebody may have collected some data about what happened, and there might be some cost information available. What I'm proposing is that we should try and compile as much of that type of information that's available out there in some standardized manner so that we can mine the existing information to try and say something about this relationship between what do you get, what's the conservation benefit for spending a certain amount of money. We can't do that currently. We can't say, you need to spend this much money to get this conservation outcome. I think that there is some data out there available to sort of start thinking about that. But into the future, we need to design data sets where we can carefully relate the the cost of the conservation intervention to the benefit that you achieve from performing that conservation intervention, and then sort of move forward into the future to be able to actually answer these questions and make these decisions to get the best conservation outcomes that we have for the money we have available. So I think I'm going to stop there and